Good day everyone, welcome. Today we will be discussing movement about a point. Movement about a point. Movement is the result of a turning effect of a force about a point. It is the product of the force and the perpendicular distance it covers. Most of the question in this discussion will be centered about equilibrium. And when we relate to movements, for equilibrium to hold, our clockwise movement will be equal to our anti-clockwise movement. Now we're going to be defining some basic terms. Now the first will be center of gravity. Center of gravity is the position where the resultant weight of a body tends to act. The next one will be uniform bar or beam. Now a uniform bar or beam is a bar or beam where the center of gravity acts at the center, the center position of the bar or the beam. Now for instance, a uniform bar of 10 meter must have its center of gravity at the 5 meter point, that is at the center. Now a non-uniform bar or beam is a bar or beam where the center of gravity is not located at the center. Now the reason is that the weight is not evenly distributed along the bar or the beam. Now we are very well conversant with the mass and weight, and any given mass in kg must be converted to weight in newton by multiplication by the given value of our acceleration due to gravity, which is our g. Also, in taking movement about a point, we also apply our knowledge of resolving of forces along the vertical component. In some cases, the diagram below shows that at equilibrium, the sum of all the vertical forces, that is sum of Fy, will be equal to 0. So therefore, from the diagram, r1 plus r2 minus in bracket w2 plus w1 plus w3 will be equals to 0. So therefore, r1 plus r2 will be equals to w2 plus w1 plus w3. So we are given two conditions at equilibrium. Our anti-clockwise movement should be equals to our clockwise movement, and the sum of all our vertical forces should equate to 0. Our very first question is from November 1992, and it states that a uniform rod 12 meters long is pivoted at its center of gravity. If a mass of 50 kg is suspended from one end, how far from the other end must a mass of 75 kg be suspended to make the rod rest horizontally? Our very first step is to try and represent our question with a diagram, and doing so will make the unknown part you are looking for to be equals to s. That the distance from the 75 kg to our pivot will be s. Now we are going to be taking moments about g and g, and we know that the sum of our clockwise movement will be equal to the sum of our anti-clockwise movement. The very first step is to convert from kilogram to newton, which we are going to be doing by multiplying by 10, since we are not given the value for g, so we are assuming g to be equal to 10. So therefore 75 kg will be equal to 750 newton, and 50 kg will be equal to 500 newton. So now equating our clockwise and anti-clockwise movement, it becomes 500 times 6 will be equal to 750 times s. Simplifying further, it becomes 3000 is equals to 750 s, and dividing both sides by 750, s will be equals to 3000 divided by 750, which will be equals to 4 meter. Our very next example is from WAEC 1994. It states that a uniform rod PQ is 20 meters long and weighs 80 newton. As a weight 20 newton and 50 newton suspended at P and Q respectively, find the distance from P where the rod must be supported so that it will rest horizontally. And we are given the option. Our very first step is to express it in a diagram. After doing so, let the point we are looking for be D. Now taking movements around the point D, we know that our clockwise movement will be equal to our anti-clockwise movement, and doing so it becomes 20 in bracket 10 plus 10 minus s in bracket plus 80 in bracket 10 minus s is equal to 50 times s. Expanding our bracket, it becomes 400 minus 20s plus 800 minus 80s is equals to 50s. Simplifying further, it becomes 1200, that's 400 plus 800 minus 100s, that's minus 20s minus 80s, will be equals to 50s. Collecting like terms, it becomes 1200 will be equals to 150s, because when our negative 100s goes to the other side, it becomes positive. Now dividing both sides by 150, it becomes 1200 divided by 150 is equals to s, and s will be equals to 8 meter. So the distance from P to D will be equals to 10 plus in bracket 10 minus s, which is equals to 20 minus 8, because s is 8, which is equals to 12 meter. And the correct option is C. We have another question from 1995 November, and it states that a non-uniform beam PQ of length 4 meter and weight 100 Newton rests horizontally on supports at P and Q. If the center of gravity of the beam is 1.5 meter from P, find in Newton the reaction at P. Our very first step obviously is to draw our diagram. Now after doing so, we have gotten a clearer picture of the question. Now to get P, or the reaction at P, we are going to be taking moment at Q to eliminate arrow 2. Now when we do that, we need our clockwise movement to be equal to our anti-clockwise movement. So equating, it becomes 4 times arrow 1 will be equals to 100 times 2.5. Simplifying further, it becomes 4 arrow 1 is equals to 250, and dividing both sides by 250, arrow 1 will be equals to 250 divided by 4, which is equals to 62.5 Newton. Our next question is from WAEC 1996, and it states that the diagram shows a light rod PQ of length 8 meter suspended in a horizontal position with 2 vertical strings attached to point C and D. Weight 2 Newton, 5 Newton and 4 Newton are suspended from the rod in position P, H and Q. Find the tension T2 Newton, that's the tension at D. Now taking moment at C to eliminate T1, and we know that our clockwise movement will be equals to our anti-clockwise movement, it becomes 2 times 2 will be equals to T1 times in bracket 2 plus 2, which will be equals to 5 times 2 plus 4 times in bracket 2 plus 2 plus 2. Opening our bracket and simplifying, it becomes 4 plus 4 T2 will be equals to 10 plus 24, which makes 4 T2 to be equals to 34 minus 4, and 4 T2 will be equals to 30. Dividing both sides by 30, becomes T2 will be equals to 30 divided by 4, which will be equals to 7.5 Newton. Our final question is from WAEC 1997, and it states that a uniform beam PQ of length 16 meter and weight 30 Newton rests horizontally on support P and Q at its ends. If an additional weight 24 Newton is suspended at a distance 2 meter from Q, find in N the reaction at P, and we are given the option. Now our very first step is to present our question in a diagram, and doing so we get the diagram as shown on the screen. Now we are asked to find arrow 1, which is the reaction at P. Now to eliminate arrow 2, we are going to take moments around Q. Now taking moments around Q, the total length of our beam is 8 plus 8, which is 16. So it will be arrow 1 times in bracket 8 plus 8 will be equals to 30 times 8 plus 24 times 2. Expanding our bracket, it becomes 16 arrow 1 will be equals to 240 plus 48, which will make arrow 1 to be equals to 288, which is 240 times 48 is 288 divided by 16, and arrow 1 will be equals to 18 Newton. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Facts Further Mathematics textbook. You can get the hard copy in bookshop, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.